Chapter 7, Lesson 4, Properties of Similar Polygons. Let's turn to page 113 in our notes. So we remember similar has the same shape, but not necessarily the same size. This is the symbol for similar. It is the result of any transformation. That means it can be a translation, where it just slides and stays the same size and shape. It can be a reflection, which is like a mirror image, which stays the same size and shape, but it's reflected backwards. It can be a rotation, which stays the same size and shape, but just turns. Or a dilation, where the scale factor can make it enlarged or reduced. So similar means that the polygons have the same shape. It's always going to be the same, just not necessarily the same size if there's a dilation. If we have similar polygons, the corresponding angles are congruent and the corresponding sides are proportional. So we have looked at this last lesson. We're just looking at it in a little bit more detail. So here's an example. I have triangle ABC and triangle DEF. I know that these triangles are similar because these are the same exact angles, and I know that these are proportional. So we're going to prove it. We're going to prove it that they are proportional, or that they are similar by writing a proportion. So when we write a proportion, remember we need to come up with a pattern like we discussed in the previous lesson. And in this example, the pattern that I chose was the slant over the horizontal of the first triangle is equal to the slant over the horizontal side length of the second triangle. Remember, we cross multiply to solve our proportion. And that's 12 times 10 and 15 times 8. They are equal. That means that they are proportional. So we can prove that triangles are proportional, or any polygon is proportional if the sides are proportional and the angles are congruent. So again, you can prove that any polygon is going to be similar if the sides are proportional. You can write a proportion and it becomes equal, and the angles are congruent or the same.